Right, in this video I'm going to talk about the hardest stuff in C, the idea of what memory is, what integers are, what data is, and what the assignment statement is. And you may think, oh, that's trivial, assignment's trivial. Trust me, it's not as trivial as you thought. So stand by while I point out the biggest single difference between C and Python. So it's concerned with what we mean by memory. In Python, when we talked about memory, which we only did vaguely, we talked about something called the object store. And we said that if you execute an assignment statement like my age is 99, then you look at a particular object in the object store called the current dictionary, sometimes called the current frame, and you look for a variable my age. If there isn't one there already, you create that name, and you work out the right-hand side and create a new integer object, which is a complicated thing of some description. It knows about the methods of an int, for example. And then you associate the name with the new integer object. And in Python, statements or code like the following is perfectly legitimate. X is 10, print X. X is 23.6, print X. X is high there. Every different step through there, you get a different type of object associated with the name X. C is not like that at all. C is essentially a structured assembly language, and what we're really doing here is dealing with the raw machine. And the raw machine does not have an object store. It's a sophisticated high-level construct built on top of the real computer memory, which is just a sequence of bytes. If you've got a 1 gigabyte machine, then there's a billion of them. If you've got a 4 gigabyte, you've got 4 billion of them. And I've represented them here as little boxes. Each box has a number in it, that's the value at the memory location, and it has a number, which we call its address. Think of these as letterboxes in a street, with each letterbox containing a number inside it. That's what memory is in C. These are 1 byte, that's 8 bits long, each of those, but they can be grouped together into clusters, which can be dealt with as a unit. So 4 in a row, for example, those 4 bytes there might be called an integer, a 4-byte integer. And if I do that, then the bits inside each of those bytes can be considered to concatenate together to form a 32-bit integer. So given this difference, in the underlying memory model, the assignment statement has a totally different meaning in C and in Python. It just looks superficially similar. So in C, when you say A equals B, you mean go to memory location B, and according to how big the data item at B is, copy that many bytes across into the memory location called A. This is just raw byte copying. So completely different to Python, which is assigning or binding a name in a dictionary to an object. So Java has something similar in its basic primitive types. Given that the memory model of Python is completely different from the memory model of C, it isn't surprising that the way we have to declare and deal with variables in C is very different from in Python. So as you know by now, if we want to use a variable, an integer x, for example, we're expected to or required to do something like declare it, int x equals 0, for example. This has the effect of saying, I wish to reserve 4 bytes, because that's how big an integer is, at least by default. We'll see other types in a minute. Call that lump of 4 bytes x and set them to 0. Then, having done that, I can start to use x. Normally, when we're programming in 260 and we want integers, we just use int. But there are more than one sort of int available. And in fact, I can do things like I want a short integer. On the lab machines, this will be a 16-bit integer. I can say I want a long int. I can say I want a long int. I can say I want an unsigned long int, or a signed long int. And these all tell the compiler about how much memory I need and how I'm going to use that lump of memory. So if I say it's an unsigned int, I'd better not go setting it to negative values. If I go unsigned int x equals -5, it's a bit of a nonsense. You said it was unsigned, and now you're trying to tell me it's signed. So there's some quite subtle behaviors in here. This table here shows you the different sorts of integer I can have. I can actually declare a very short, super short, a short, except I can't do it. I can say char x equals 0. This declares a 1 byte integer. I can have a short integer. I normally expand it in full. You can drop the int, but a short integer is a 16-bit job. The default integer, which is what I get if I just type that, is the same as a long int, which is a 32-bit integer on our lab machines. And I can also declare a long int, which is a 64-bit integer for very long numbers. I think what you might see in the second term 4 if you prefer, the uses of some more explicit data types. Like I can write int8 type, int8 underscore type x equals 0, provided I've imported stdint.h. I should have, sorry, hash include. So if I go hash include stdint.h at the top, the standard integer types, then I have expanded data types, and I can say explicitly how many bits I want them to be. Int 16 type, int 32-bit type, and so on. Int 32 underscore t, or I might want an unsigned integer 32-bit type, and so on. So this is annoying, much more restrictive in C than Python. I have to say exactly what sort of use I'm going to make and what range of integers I'm going to try and put in there. As you've seen in Lab 1, if I try and put an integer in there that's too big, well, she's right, it just rolls around and turns negative, or something else equally weird. There's also a couple of other data types that you need to know about at this stage. One is float. This is a 32-bit floating point number, and it's not the same type as Python's float. Python's float in C is called a double precision float. We'll come to those in a while. That's all I wanted to cover in this particular video. The main takeaways should be the notion that memory is just a sequence of bytes. The meaning of an assignment statement is to copy a lump of memory from one place to another, and in order to deal with these different elaborate types, you have to declare in advance the names of the variables you're going to use and how big they are in order to know how much data has to be copied when you do an assignment statement, and also generally you should initialize them to some known value or you'll get random effects. Thanks for watching. Bye.